Well, we are back for a part two of our opening podcast series on an overview where we've come from, where we are, and where we're headed in the natural gas industry with Norm Shade. So, Norm, I'm just going to let you pick it back up and ask you a few questions along the way.
Sounds good. So for those of you that missed it, there was an earlier podcast that kind of gave history and build up to the current state and kind of left off with, things look great, except. So now I'm going to try to focus on a little more of what I think is needed for success in the future. I want to emphasize that a lot of the slides have been borrowed from prior presentations and give credit to those. Some are also new, and also a disclaimer that these are my opinions for what they're worth, so use them at your own risk. They may or may not reflect the opinions of others. So I stopped the last presentation with this slide. It says industry challenges moving forward, and there are some. We're going to have to adapt our practices, our products, and our technology to deal with this. So we have a lot of pressure from renewable energy sources. The public doesn't have a good perception of us generally, something we really have to work on. And clean natural gas is, in most people's mind, an oxymoron because it's a serious greenhouse gas. So these are all challenges that we face. However, methane is a critical part of our energy future. It's crucial that our policymakers understand that and not pursue a path that eliminates methane as a key element of the strategy to reach environmental goals. You can't get there, as I showed in the last presentation, without natural gas. You can't get there in the foreseeable future, and you can't begin to get close in the time span that some of the politicians would advertise or set as goals. And there shouldn't be hysteria fed by the occasional unusual and unprecedented incidents that lead to misdirected conclusions that natural gas is a valuable contribution. I want to talk about there the occasional pipeline rupture and explosion, the methane leaks out of wells that happen in Southern California. I mean, those are bad events, and we absolutely have to avoid them, things that injure people. However, got to be careful it's not an overreaction to it. And the press is going to feed that, and it's something we just got to live with. Much of the opposition to natural gas, though, stems from the fact that most of the methane that we currently consumed is prehistoric. When you look at time, it took eons to generate that hydrocarbon, and we're releasing vast quantities of that sequestered carbon in the form of natural gas into the atmosphere, either by burning it or just natural, in a blink of geological time. So that's the problem. We're just up. So we do need renewables. This resource will exhaust itself. It will run out. So it's all good for society, for humanity, that other sources of energy are developed, but it can't be done with a flip of a switch. Releasing and burning prehistoric methane is not without its consequences, particularly the climate, and we can continue to use methane while reducing the negative impacts by displacing prehistoric methane with renewable methane. So that's a new concept for some. Let's talk a little more about that here. What is renewable methane? Can that be the clean fuel for tomorrow? We really should get credit for that if you use renewable methane, because you're preventing it from going to the atmosphere. It's not prehistoric methane, it's new methane that is being generated and not being sequestered. So if we can somehow use that, that's good for us. In comparison to coal and petroleum, it's good for burning. It's the cleanest of the hydrocarbons, so it's, say, the best of, many undesirable fuels in some people's mind. It doesn't need fracking. It doesn't typically put our water quality at risk. It doesn't affect seismic activity and all the things that tend to be the bad knocks against development of our shale resources, right or wrong. It doesn't typically have to deal with those. And we need to remember that the once good slogan of clean natural gas has become tarnished, and it's really out of vogue. I mean, people look at you when you say that like are you nuts? And maybe we are when we say that. Most recently, there's concerns about the effect of methane on greenhouse gas, and we talked about that in the last presentation. How it's as much as an order of magnitude worse than CO2 by most analyses. And so is the clean natural gas slogan even repairable? I don't know, but maybe it is if we can use renewable methane. So it's a positive spin at any rate. It's one strategy going forward to, I think, exploit. And the neat thing is we can use our infrastructure to transport it to market, and there's lots of benefit. So it's the idea of capturing methane from dairy and agriculture, managing our landfills. And, there's a fair amount of that done today, but most of it's done for power generation. But you could also capture it and pump it into the pipeline. It takes a little processing. You got to clean it up because it's got a lot of nasty stuff in it. And we could also use it to make hydrogen. And hydrogen is kind of the hot topic nowadays in a lot of circles, especially outside this country. But Shell, for one, worldwide is doing a lot of work with hydrogen refueling. And I'm involved in one of my consulting projects with Shell Hydrogen to help adapt some of their compressors. Actually got two projects going on with compressors for hydrogen. And also, it isn't on that slide, but digester gas from sewage treatment plants and things like that is another big source of natural gas, of methane. Another is natural gas reforming, where you can take natural gas and produce hydrogen. That's the primary way hydrogen is produced today. I'm going to say going forward, the ultimate answer for hydrogen probably is to use renewable energy to generate it from seawater. It's very very energy intensive, but if you can use renewable energy, say in peak times when you don't need all of that to make hydrogen, and then you have a way to store it and transport it, that's one little piece of the solution to the storage of renewable energy.
And you said the main way is from the sea?
Is what?
How did you say the main way for doing that with hydrogen?
Today, it's this slide here, the natural gas reforming is today making it from natural gas, but in the future, they make it from seawater.
How's that?
Well, you use an electrolytic process and you dissociate H2O into H2 and O2, okay?
Okay.
That's the chemistry. But it takes a whole lot of electricity to do that.
Right.
So it's only economics, say, with renewable energy, excess renewable energy. But hydrogen is a really neat fuel. When it burns, it basically is water vapor, and so it's very clean. It's not very easy to store. It's a very, very small molecule, and it finds its way literally through the grain boundaries of the material. A lot of steel or a lot of materials can't tolerate it, and it also you have to store it at very high pressures to get enough mass to be of use. So,
is that you said you're working on a project with Shell? Is that part of it, or are you talking about just compressing it? Or is there anywhere in the country that's kind of developing a way to?
The Department of Energy has had some pretty strong development programs for a decade now. But if you go to Europe and Korea, Japan, they're using a lot of hydrogen in fuel cells. You don't burn it in engines, you burn it in fuel cells.
Right.
And those are in vehicles, and you have to have refueling plants. So you have to build the infrastructure. So what Shell is doing is providing the infrastructure, for providing the fueling sources, fueling stations. And there's cars and trucks that do run on the stuff. You pull up and you have a fast fill, a lot like CNG. The only difference is CNG is delivered into the tank at say 3,000 to 5,000 pounds per square inch. Hydrogen, you pump it up typically to about 800 to 1,000 bar. Okay, so that's 10,000 to 15,000 psi.
Wow.
So if you're scared of natural gas or CNG tanks, you ought to be scared of hydrogen tanks. But they're overcoming those issues. But those are some of the challenges. But it is a really clean environmental fuel, and that's probably one piece of the puzzle. And what's interesting to us is that if we can mix it with natural gas in our lines, we can move it around.
Can you do that? You can run it in the same line?
Well, we're going to talk about that.
Okay.
So this is a little more about what I already talked about, the benefits of hydrogen energy. I mean, they power spaceships with it, okay? So the technology is well proven on small scales when you've got infinite amount of money.
Right.
But it has some disadvantages. It's expensive, storage complications. It's not the safest, and it's tricky to move around. And it cannot sustain the population, but it's one piece of the solution. So another new technology that probably we're going to see growth in, and unfortunately this requires compressors, is carbon dioxide capture and sequestration. So the idea is that you capture CO2 from power plants or other large sources of CO2 production, and you basically drill down into the ground and put it in a reservoir that's going to capture it. And so you're restoring that hydrocarbon or that carbon molecule back to the earth. You can actually use CO2 and enhance oil production, enhanced oil recovery. The problem is most of the large sources of CO2 are not close to the oil fields. So you can put in CO2 pipelines. CO2 has its own challenges. The stuff you get a little moisture and it's very corrosive. And it's a gas that depending where you are on the Mollier diagram, you get close to liquid dome and it'll turn to liquid. Compressors don't like that stuff. So it has to be dealt with carefully. There's some other technologies out there. There's a new plant down around La Porte, Texas, that actually is a net zero natural gas plant. And they use natural gas as a fuel, but they burn instead of air with pure oxygen. And so it gets rid of all the NOx, which is from the nitrogen and air. It's called the ACI cycle. You can look this up on the internet and learn more about it. What I've got here is everything I know about it, but it's an oxy-fuel power cycle, and that may have some potential. So the air separation plant nearby, you strip out the oxygen and you send that to the power plant, and it's a potential game changer maybe for the use of hydrocarbons.
So let me ask you a question. When you say they're burning natural gas with oxygen instead of air, is that obviously compressed? I mean, the oxygen, they've got to...
It is. I'm not positive on that one. You can also, boil it off and use the pressure of the boiling off process to generate pressure, but usually it's got to be compressed. Oxygen compressors are a special breed of their own. You can't have anything combustible, even fragments from cloth,
Right.
Or fuel source. So oxygen compressors, I've worked on them a little bit, and I'll just say that's something I'd rather not get involved in.
Maybe that's why there's only one of those plants.
Well, it does have its own problems, but again, technology will overcome that if there's a benefit.
Right.
So we can recover, reuse, and recycle existing hydrocarbon, and maybe that's the way to, get back to the clean natural gas slogan. I don't know. But we talked about renewable methane as a way to reduce methane loss to the atmosphere and put that to use. And we talked about where it comes from. And that's something that, again, could use our existing infrastructure and used by our legacy customers. So that one's like a no-brainer in my mind. This exploit the heck out of that.
Yeah.
And let's advertise it. Let's get some brownie points for that.
Right.
So let's look a bit about in time we've got here in this session at the compression outlook. Most people will be familiar with this, but just a little bit of recap. There's lots of compression options, and I'm going to talk about upstream or midstream here and then upstream in a moment. Traditionally, the pipeline infrastructure was built with integral engine reciprocating compressors, big units, and not so big units to start with, but When Cooper stopped building these, the largest unit was 12,700 horsepower. A 20-cylinder recip with 20-inch bores and 20-inch stroke. Big machine.
Yeah.
Pretty unwieldy machine too.
Yes.
Slow speed recips driven by electric motors, still a viable technology and very, very efficient and a good solution, but a little more costly. You need a foundation for it. What's most popular and what dominates are the high-speed separable recips driven by gas engines, as you see in the top, or electric motors, as you see in the bottom. And of course, gas turbine or electric motor-driven centrifugals, which largely fit on pipelines. You don't see many of those in the upstream. You see a few, but really they're for nice, clean gas, high volumes and low ratios.
Let me ask you what may be a stupid question, but 10 years ago, we built, I don't know, 40 or 50 packages. They were for New Mexico. They were frick packages, and we use natural gas engines. So why is it not more of a commonality to use natural gas to run and supply energy for the compressors?
Well, it's the preferred solution. You can use electricity if you've got. I mean, you kind of use it if it's cheap, and it usually isn't cheap compared to gas unless you get hydropower around.
Right.
And you can use it if you have to because of environmental air emissions regulations. Some places you literally can't get a permit or you can't add horsepower. But you have to have electricity available. And I remember 10 years ago, it was $1 million a mile to run a power line if you can get the right of way. So electric is okay. But then there's the other issue like you saw in Texas. If you have natural gas powered power plants and you have compressors that are driven electric motors, you got a chicken and an egg proposition. You can't get the power to the compressor plant to provide the gas you need for the power plant. So again, infrastructure problems that nobody has looked at big picture. So we have to get more intelligent, smarter, and kind of get our head out of the wrong place. Anyway, integrals have been around a long time. First introduced in the 30s, almost 100 years ago. Quit being built in the early 90s, except for Ajax is still around. Okay, that's one that's dear to my heart because I ran that business for a time. But under 900 horsepower, and a few of those are being reapplied, and certainly there's upgrades to them. But the larger ones really are the ones that are still being used. Slow speed recips, very viable and fairly popular for CO2 injection because CO2 being a heavy gas likes slow piston speeds. Mm-hmm. And it's real problematic trying to push that stuff through valves and high speeds. So they have a place and probably will continue to see those. There aren't many producers of those anymore. Most are outside this country. High speed recips are pretty much where it's at. And they're relatively new in terms of overall history. First appeared in the late 50s and really developed quickly. They dominate the upstream. You mentioned rotary screws. Yeah, rotary screws have a place too, but they're limited by pressure capability. Right. So they have not enjoyed the surge that their small recips have had. You need more ratio and more ultimate pressure capability that typically the screw can produce. So they fit coal bed methane, they fit booster compressors at wellheads, and they have their place. Fuel gas boosters for power turbines, they have their place, and I won't talk about all those, but mainly I'll talk about the gas patch. So lots of advantages to those machines. There's a lot of packagers. So, a lot of cases it's almost a commodity, right. I put up my spec and I take the lowest price and the shortest delivery, and I'm fat and happy, but they have to be done carefully. They need, especially as they get larger, they have to have special analysis for vibration control. They can produce some nasty pulsations that tune up with mechanical resonance and can cause a lot of reliability issues. That can all be done right, and it can all be done poorly, and I've seen both. They can be low emissions with the technology available today, and that's only going to get tighter. And there's, big units from 750 RPM up to high-speed units at 1,800 or even a few higher. And you can do electric motor drives as well as gas engines. Centrifugals I won't spend a lot of time on, but they're out there. They were first introduced also in the 1950s. The first centrifugals, oddly, were run by, big heavy frame gas turbines, but then 4-cycle gas engines with gearboxes. Cooper did that many, many times until they got their own gas turbine. So that's a good solution for pipelines. I showed this slide earlier that shows the trend for compressor stations for pipelines has been growing. Size of unit has grown, and that's because there's bigger units, smaller units retired, and most of the big units are centrifugal. So you asked in the last session a question about that, and there's the answer. So I continue, I don't know, if you blow it on out a ways, it says that they're going to continue to go that way. And bigger stations, probably the way it goes just because of economics. It's hard to site a new station. It's hard to get an expansion of a station, but it's a lot easier than getting a new station in place. Mm-hmm. It's really getting hard to get a new station sited, especially out east.
Is that political and environmental issues?
Special interest. Even after you get it permitted, somebody files a lawsuit and said, FERC or EPA, you didn't do your due diligence. They contest it. It ties it up in court. There's stations have been tied up for years, and meanwhile the cost goes up. The need changes, and there's been a number of cases where the pipeline company finally throws up his hands, so they give up. So there are very effective ways to fight it, and now the banks are even being pressured, but don't invest in fossil fuels anymore. So it's politically you can argue about what's going on in this country, but there's a lot of opposition for various reasons. But the stations tend to be big. Okay, there's a gas turbine plant on the left out northeast. There's one on the right that is one of the bigger recips put in the last decade or so in Arkansas. 78,000 recip horsepower.
Golly.
Gas turbines, I'll kind of flip through this. There's some examples of some of the bigger recips, and they're available, they're out there, they're proven. Let's look at upstream a little bit. Certainly the factory-built packages have become the norm for the upstream. They can range from little guys to bigger guys. CO2 package, again, a nice opportunity, I think. The Ajax Integral. A couple of manufacturers, certainly the Cat Ariel is the most prevalent, but there's Waukesha prime movers. There's some other engines around in the smaller sizes. They're still superior. They're still Ajax, Siemens, Dresser-Rand products, and the old GE Gemini HSR product line. What is the trend, though, is especially for gas gathering and gas boosting, is that more so than wellhead compression, and even for gas lift, you're seeing kind of central units. You're seeing banks of compressors. The one on the upper left, right there, there's, I think I counted 12 units, and they're Cat 35 16s, I think they were. Mm-hmm. But so that's a fair amount of horsepower, not a lot of units, but they're in parallel. And it's kind of flexible. You can bring it on as you need it. You can modulate with turning units on and off. So it's the way things are done. And it's a lot easier to build that one site than to build, 6 or 12 of them. So the trends in the upstream, larger compressors, 1,200 horsepower to maybe greater than 2,000 now, multiple parallel units. Existing shale compressors are likely to stay in place until the latter part of the decade. In other words, what's there is probably going to stay there. You need it. The shale pressure declines. They drill more wells to make up the gap to some extent, but eventually it declines. I'm concerned that the restriction on capital for fossil fuel projects may limit new shale play development in the future.
When you say restricting capital, who's doing the restricting? You saying banks not allowed to invest in that?
Exactly, or they say, well, this is a decline in industry. I'm going to put my money in green energy. Or you see a lot of pressure on boards, to have what is it, ESD, or you got to have social diversity. You got to have all this stuff, including environmental consciousness.
Mhm.
You got to reflect that in your actions. So the banks are under a lot of pressure, and they're going to put the money where the return is, where the risk is low. But it's certainly not more to get that capital investment. It's harder and harder, I believe. But anyway, when capital is intensive, it favors rental compression because you can rent that when you're in production. You don't have to invest in it. At some point, more compression probably is justified at the wellhead as wells mature. You got to add compression to boost them, and that's going to be probably smaller units, or they could put in boosters at the central gathering, but it's probably going to favor screws for low pressure. And it's going to be more cost effective than drilling more wells at some point. So those are longer term trends. I don't know when that's going to happen, but it will happen.
Yeah, the rental thing seems to really, that's in Texas and the Permian, that is for sure how things are going.
And it's largely driven by availability, and I don't have to spend my capital dollars.
Right.
I don't know what I need, so I'll rent it. If I really know what I need, that's actually kind of foolish a lot of times because you don't know what the production's really going to be until it's running.
Right.
And then there's going to be extreme environmental regulations with, I believe, severe penalties. So it's not going to be a nice to do thing. It's going to be a have to do thing. If you have some minimal exhaust emissions, little or no methane release is going to be grave consequences for methane release, and probably a carbon tax, which we're seeing in some developed countries already.
In your consulting business, is that coming up in wins? Are people reaching out saying, hey, Norm, how in the world do we get from 5% to 0% of methane loss?
We run into it in various ways, not as projects, but gas questions like, well, how can I recompress the gas from a blowdown rather than venting it to atmosphere? Things like that. How do I do that? What I do with the vent gas, recompress it, do something with it, burn it, I guess, if I have to, because that gets rid of the methane at least.
Use it for gas lift if you can.
Yeah. So all of those things are going to be, I think, more on the radar, and probably need to start really quick, and probably will be legislated soon, depending on what, if they can get through Congress. But if the Democrats, maintain the majority, then it'll absolutely happen. If not, then it may slow down. But there's a lot of pressure on everybody to be environmental conscious. Whether you agree with it all or not, it's going to happen.
Right.
So these are some of the things we're seeing. The technology is pretty much out there, but the one on the upper right, I think, is going to become more normal, where you got to use urea or ammonia injection for selective catalytic reduction. Expensive, nasty to maintain, but it does get rid of the NOx. And then we got to report and control greenhouse gas. And there's cameras, you can go around to sites now and film the hydrocarbon, and believe me, there will be people doing that, and there'll be incentive, there already is in California, to turn people in, bounty hunters.
Right.
So lots of options for compression, upgrader and integrals, high-speed recips, gas turbine-driven centrifugals for the midstream. Consistently lower exhaust emissions. As I said, probably SCR will be its best available control technology, and probably mandatory. Concerned about the two-cycle engines. Really, Ajax is the only one still built, but the existing ones, there's a lot of methane, what's called methane slip, uncombusted methane. There's people studying how to reduce that, because it goes directly to the atmosphere, and it's been largely overlooked by EPA, but it's on the radar. Wide and usable speed ranges, because remember that flexibility I told you to, you're going to have flexible compression. So multiple units you can turn on and off, or vary the speed, or lots of unloading. But when you have variable speed, you have a lot of vibration frequencies to deal with. So you got to do some very comprehensive studies, and you need flexible automatic control. You can't do it manually. You got a variable unloading on recips, and I see a lot of retrofits in the horizon for upstream, and variable IGVs and guide vanes for centrifugals, so they can be more flexible. Centrifugals are great, but they're not very flexible. They have a narrow operating range that's efficient. And then if you get too low in flow, you have to recycle gas. So you're burning the fuel and pumping the gas around in a loop. I talked a little bit about black start capability. If you burn natural gas, you can start generally with what's in the line, you need a battery or an air start tank to get the unit running, and then you can go. But if you're running an electric motor, you're screwed if the power's cut off. So that's a demonstrated issue that hasn't been solved. I needed higher operating efficiency at not only on the unit but at the site. So all that waste heat that's going to the atmosphere, can we use that? Can we productively employ that and recover it and make money? And then literally no methane loss to the atmosphere. So better sealing, capturing what is vented, or typically capturing our blowdowns, things that I talked about a little bit. And overall, we got to have a greener footprint. Perhaps we use renewable energy for auxiliary needs, maybe dual drives, and we'll talk about that briefly here. Centrifugals, similar needs. I won't go through all of these. Other opportunities, dual drives. The thing about a dual drive, it's basically a compressor with two shafts. Got an engine, gas engine on one side, you got an electric motor on the other side. And you can run either as the driver, or you can run excess engine power through the compressor and drive the motor as a generator and sell into the grid. So you can make money. Okay, you can help provide perhaps some of that gap.
How far are we away from solar energy being, I know we can't store it, but being able to generate and run? I've got a friend that sells pumps in the landfill space, and they've developed these pumps that can run solar without anything to them, and they move quite a bit of product. But how far are we away from using solar to power a package out in the field?
Well, short answer is I'm not sure, but conceptually, I think you can generate the solar energy, but you then have to store it, and you have to convert it probably to you got to convert it to whatever the motor requires.
Right.
So that technology all exists, but is it available on a commercial scale? And then can you use it when you need it? I guess so. It's an issue of having the demand to use it versus the capacity to store the extra. But that's all viable, but it's probably not commercially economic at this point. Some other quick ideas, though, is that LNG production and storage at power plants. You can transport gas most any time through those power plants, and during the off-peak, you can make LNG. So now you can build up your stored capacity for the downtime. So I think that while an LNG plant is not cheap, that compared to an underground storage facility is I think a growth opportunity for somebody who wants to think about investments, and those will be some of the gap stoppers. That renewable gas compression we talked about, the capture of carbon, transporting it, injecting it, including enhanced oil recovery. Hydrogen transport, Kinder Morgan says 5 to 10% should be doable. There's some debate about that. Not the least of which that 10% hydrogen changes the acoustic natural frequency of the gas by something approaching 10%.
Wow.
Station tuning and the acoustic resonance of piping now may be an issue. So it's not just a matter of doing it. It takes a little bit of study. And there's some studies being done to assess that right now. It's a hot issue. So getting close to wrapping this up here, some of my opinions. Methane leaked in the atmosphere, whether at the wellhead, from leaking scrubber dumps, from piston rod packing, or anything else, is viewed and is a serious contributor to climate change. We got to clean up our act, and we got to do it urgently. It's not something that's nice to do. It's something we have to do. Our image is not good, and it's getting worse, and we have to really walk the talk. Our practices and our technology have to improve. We have to prevent accidents. We do a really good job, but whenever we have an incident, it gets overplayed, and that's very, very damaging. We got to eliminate, for whatever reason, we got to minimize, if not eliminate, exhaust emissions. We got to increase our efficiency. We need to burn less gas, on the way to market. That's more gas cubic feet delivered
versus CF cubic feet consumed. And we got to advance the technologies like carbon capture, carbon neutrality, carbon neutral, okay, renewable methane, hydrogen, and so forth. And our public perception has to change urgently. We've got to walk the talk. We've got to sell the public on important facts to change the narrative about natural gas. And don't expect help from the media. We're on our own. So
do you know of anybody out there or groups besides, some like Gas Compressor Magazine, all these, is there actively groups of people out there doing that?
There are, but it's a drop in the ocean because who's listening to them? It's us, right? Eastern Gas Roundtable is putting out a thing every week. INGA has some good stuff. Southern Gas Association, American Gas Association, GMRC, all have excellent material, and you ought to go to their websites. The problem is nobody goes except us.
Right.
And so we have to be the missionaries. I don't know what else to do. Your family, your friends, and I'll get on the soapbox here if I'm not careful, but there's no other alternative. The media isn't going to do it. It's not interesting. It's not cool. People, it's not sensational.
Yeah.
So how do we change the mindset? I argue with some of my college student grandkids, and I have one that's become an environmentalist, and she has done a study and she understands these gap things. I said she's seen the light.
All right.
She's very liberal, but she voted liberal, but she understands this issue. I said, okay, talk to your friends, talk to your professors. Some best practices training. There's really a shortage of personnel with experience and problem-solving skills. That's been a problem that's developed here for a while. We've had historic up and downs in this industry. There's literally generation gaps of knowledge. Experienced operators, service personnel, and engineers have been retiring at a rapid pace, and that's been ongoing for a while now. Mm-hmm. Traditional manufacturers have consolidated, and many disappeared entirely. So, how do you get the support for the existing equipment becomes a bigger and bigger issue. And there's, fortunately, some companies around to fill that gap, but it is not what it used to be. Younger generations, in my opinion, are better at searching the internet than thoughtful diagnosing of problems. That's just not taught. And it's not something that you're born with necessarily. It's a learned thing. Cost cutting exacerbates the problem. About the time we get some new people build up, we have a downturn, and they're the ones that go out and, well, they probably leave the industry, okay? So you start over. And many don't know what they don't know. Maybe good people, maybe well-trained, but they don't know what they don't know. So what are some solutions? Well, few institutions at any level teach our industry's specific knowledge and unique technology. So entry people have limited capability. So what do we do with some of these things? Well, there's vast information on the internet, but we got to use that wisely, and we got to use it from trusted sources, obviously. We need to promote and utilize, I believe, community college training programs. They're low cost, they're local to some degree. And we can use that for basic, introductory, but also continuing education. And a lot of that can be online. One of the things that the pandemic, I think, will demonstrate is that we've gotten really good at online everything. So like this podcast, the training.
Correct me if I'm wrong, but the book that you just wrote, An Intro to Compression, that's going to be used for college training, right?
That was the primary reason that I started it, because those programs were big a few years ago when things were ramping up so bad, and they didn't have a textbook. So I said, I'll write you one, but it took me several years to get it done.
Are you have plans to digitize that so that people could use it online? And
not at the moment. Actually, the rights belong to Third Coast Publishing, and Brent Height may elect to do that if there's demand, but obviously he's got to recover some investment for
sure
covering, editing, and publishing of that. So I've written it, and it's in his park. But obviously, I'm biased, but I think it's a good resource and it's a good training tool.
It is. I'll vouch for that.
So, manufacturers offer training programs, person and vertical, take advantage of those, get everybody trained up. And, you usually can't tell people one time, you got to repeat it.
Right.
So continuous education, employer provided training has to be continuous and ongoing. HAZOP reviews, hazard and operability reviews are key. That gets people thinking about how does work, what go wrong, what do we do in the event, and then implement that. That's very, very important because it helps people, forces people to understand the systems they're operating. And again, some shameless plugs for some of the things that I've been involved in, but there's some good industry guidelines. The GMRC has done some good things. The first one, we realized that there was really no good guidance for torsional vibration analysis and measurement on reciprocating machines. So we wrote a guideline, and it's the best thing in industry. It was done by industry experts. So I got to lead them and I got to coordinate them, but really that came out of the, really 5 companies that do that for a living. The high-speed compressor guidelines, one for natural gas transmission and storage, which is the big units on pipelines and storage facilities, and then one for fuel gas applications that we did, kind of above and below 2,000 horsepower is kind of the logic there. And then currently something that's been sorely needed for a long time is API 11P, which has kind of been the package standard for upstream packages, is woefully out of date and inadequate. And so we actually have a 3rd edition committee that's been working now for a couple of years and probably has a couple of years left.
Yeah.
But we're working on it, and I'm co-chairing that work. So I won't retire at least until that's done. And then there's other training tools. I've plugged my book a couple of times, but seriously, that I believe is a useful tool for people to get educated or read up and say, how does that work? Okay. And how do you calculate something? And it's not terribly complicated, but if you want to see what affects what, you can kind of go through the equation and say, oh yeah, well, the suction pressure does this, or the gas mole weight does this. So can at least give you an idea to make judgments with. And then other things that the industry can do, like this podcast series is great. That's why I decided to get involved and support this. And then I'm working on another series in Gas Compression magazine that I title What Went Wrong? Sharing some experiences that I've had with when things went to hell, what happened.
That's great. And I'm just thinking through that. If you ever, we could do maybe even a separate series, but that's really interesting to me, the historical perspective of looking back at what went wrong and how do we fix that. So I'm really excited for that.
To read those monthly in Gas Compressor magazine. I think we're 6 months into it now, and I've got enough for probably 2 or 3 years.
Awesome.
And I'll probably steal from other people after that. But I'm going to do a presentation at the GA Expo in August entitled that, where I'm going to share several of those. Some will be entertaining, some will be tragic, but it is what it is.
They're important stories to tell, for sure.
Yeah, and people make the same mistakes over and unfortunately painfully relearn things, myself included. So, and then, there's other things. And even reading the history, for compressor tech, for 12 years now, I've written articles monthly on the history of gas compression, and I'm working on a book on that whole subject. But it's important to learn how we got to where we are, I think.
Yeah.
And so lots of stuff going on, and I'm putting a lot of my energy into do what I can to pass on the knowledge. So I need to wrap up here, but to finish this segment, we kind of went through in the first and in this session, the big picture of the industry and where we think we need to be going and what we got to be doing. And I'll emphasize that time's of the essence for change in every industry. There's no choice. We got to do it to survive.
Right.
And I hope this presentation has stimulated some thoughtful discussion, and I wish you the best of luck in continuing on with input from lots of other folks that share their knowledge and experience, and make this something that you can document, you can have available for people to pull up for ongoing training.
Exactly. And that's what it's for. And I, on behalf of everyone in the industry, you have been very generous with your time and talent and experience and helping us get this stuff out there. So I cannot thank you again for helping me kick this off, and look forward to seeing your work in the future.
Glad to do it. Good luck to you, everybody.
Thanks, Norm.